Okay, that's the overall shape of the drawbar. We're gonna have to put some flats on this end in the mill in a little bit, but next thing we need to do is turn down the end of this to a 1/4 inch and thread it 1/4 28. I think I can open this up enough with just 2 jaws, yeah, to get that in there. With any luck, we'll be still close to centered up. Let's get an indicator. Okay, make sure we're going to have 800 thousandths we need to turn down. I can probably pull that back just a bit. Make the setup just that much stiffer. You can't see that, can you? That better? Yeah, that's better. Okay. No, these other jaws were loose. It's less than 1/2 thou. Let's make sure everything's really tight. Yeah, we're really on it. Okay. I'll deal with that. Less than 1/2 thou works for me. Okay. Let's spin this up nice and fast. Okay, I'm just going to lightly touch the end here, and then I'm going to bring the indicator out. Zero that. Then I'm going to go in 800 thousandths. 1, 2, 3, 4, 5, 6, 7, 800. I'm going to lock this temporarily just so it doesn't move on me. While I'm screwing around with the indicator. Okay. And then we'll set a 0. There we go. So that's the end. We want 800 thousandths. And just as a sanity check, yep, that looks good. take 10 thou. So 416. Shoot for maybe 248. Means we got 168 or 84 off of each side. So let's take some 20 thou passes and see where we end up. $20, $40, $60, $70, now let's see where we are now. 277.3. Is it the same out here? 277, yep. Headed for 248 means we need to take 29.5 off, divide that by 2, and we need to take 14 off of each side. So let's take 7. $264.8. Headed for 248. Means to take 16.8 divided by 2. We need to take 8.4 off of each side. 3. Take 8.5. I'm going to slow the feed down here a little bit. $248, $247.95. There's a little bit more out here, $248.55, just because it's unsupported and there's a little bit of tool pressure and flex. Okay, now we need to thread. Let me set up the change gears for threading and I'll be right back. Okay, I've got the change gears in here set up to run 8 threads per inch. Haven't tested it yet. And I've got a carbide threading tool. Should be set up now to run at 150 RPM, nice and slow. And now the first thing I want to do is come in here and put a little thread relief in the back. Now, ideally, the We should be running with a flank length of about 25 thousandths, so that's about how much I'm going to feed in, maybe 30 thousandths on the compound as I'm cutting the thread relief. And that should put us just about where it's going to be on the final thread. Come in here and touch off. And that's where I'm going to set my 0, and I'm going to feed in with the compound. There's 5 thousandths, 10 thousandths, 15, 20, 25, and I think I'm going to go all the way to 30. So there's 30. And that is our thread relief. Okay, now let me back this compound back out, bring it in to 0, then I'll bring this into 0, and we should be just making contact here on the end. Yeah, very close. I bring it back -2. Okay. Let's make that our 0. Okay, I'm going to make one pass here just to make sure. Get my thread dial engaged. And I'm going to make a scratch pass and then check it with the thread gauge. Make sure we're really at 28 threads per inch. It's 26, 27, there's 28. Yep, that looks like 28. We're in business. Okay. Let's cut some threads. Let's take a 3 thou pass, nice and light, just to make sure everything's looking okay. That looks good. Take a few more. Waiting for my number to come around here. Okay, this will be for a total of 10,000 steep. Take 3 more, no sense getting in a hurry here. Okay, this will be a total of 20 thou on this pass. That's 20 thou on the flank. Before we get too excited, I'm going to put just a little bit of a lead in here on the end. I'm going to take 2 more. Now I'm going to take a spring pass right there and see where we are in the threads. Don't look too bad. I have a piece here that I tapped earlier, quarter 28. The idea being that this will be the size of hole, or this will be the size of tap, excuse me, this will be the size of thread that will be in the other parts because I'm going to use that same tap. Okay, and we're definitely not there yet. So this will bring us to 25 thousandths flank length, so feed in on the compound. Waiting for my number. There it is. And I'm going to go ahead and take a spring pass on that just so we know exactly where we are. And I'm not really getting anything on the spring pass. It's close. Okay, let's take another thousandth. that really cut much. Another thou it is. So now we're actually at about 30 thou on the flank length, which is what would have been predicted, 25 to 35, kind of depending on the initial diameter. I didn't really cut anything, so let's take another thou. I think we're just waiting for the tool pressure to build up enough on this carbide to actually take a cut in this steel. There we go. And that'll likely be our last cut. That's nice, no discernible rock. Let's clean those threads up a little bit, see where we end up. I'm not moving the compound, so I can always come back with the other tool. No discernible motion, but it's nice and free all the way to the bottom. I will take that. I'm going to do one more thing, and that is I'm going to drag a triangular file through it. Just trying to round over the crests by hitting this with a triangular file at one angle and then the other. Very lightly, I'm putting very little pressure on it. I am using the file to round over the edge of the end of the drawbar though. That's going to be great. Nice tight machinist fit. And the reason I care about this, and the reason I went to the trouble of single pointing these rather than just trying to come in with a die, well, besides the fact that I don't have a die in this size, or a die holder. That's a future project. That video will be coming someday. But the reason I wanted to single point these is because I wanted the concentricity to be as exact as possible and the fit to be as tight as possible. There's a register on the other end of this drawbar in order to make it fit tightly into the spindle, and that supports one end and keeps it concentric, and then the threads in the collet are on the other end, and that's what keeps it concentric on the other end. That keeps the mass of this drawbar, when it's spinning in the spindle, centered so that it doesn't cause a balance condition. Well, I think that's it. We just need to go over to the mill now and put some flats on it. Okay, to put flats on the end of the drawbar so that we can turn it, we're going to hold it in a collet block here in the mill. And I've got this set up. This is a square collet block, ER40, and I have it set up in the mill vise against a stop so that I can flip it over and reclamp it in the same position. So this is turned 7/16. I've got a 7/16 collet. Snap that in. Mount the drawbar. I got a wrench here to tighten down the nut. Okay, I've got a 1/4 inch carbide end mill, and I'm going to bring it down and just find the top, and I'm just going to touch off on the top and then bring it down the correct distance and just touch off on the side and use that as a 0. Okay, there's my Z0. Then we'll come off of the part. Now let's see, how far down do we have to come? We're at 750 and we're headed for 630. Let's make sure that we really are 750. Okay, I got the mic zeroed. It was a little bit off. A little bit concerning, okay, but yeah, there we go, 749.85. So we're at about 750. It's exactly what I expected, and we're going to try to go to 630 across the flats. So we need to take off 120 thousandths, divide by 2 is take off 60 thousandths, and I think I'm just going to dial down 55 thousandths. Okay, and then we'll come in until we touch. There we go. So I'm going to 0 the X there. We'll come off the front, and total we need to go in 250 thousandths. So let's go in half of that. Let's see here. Let's go in about, let's try 2 inches a minute at first, and let's just see how it cuts. That's going well. Let's put a little coolant on there. Let's go into 245. Cut the other way. Okay, I'm just going to dial it down to full depth and to the full width, and then take one more cut across. Okay, that's one side done. Let's flip it over and do the other side. See if we can get in this way. And looks like we're right about 627. That is going to be close enough. So what that means is the 16mm wrench should fit on that. Here's a 16mm wrench. There's a little bit of a burr, but that fits beautifully. Okay, we're done. Let me break this down. Let's go over to the bench and take a look. Well, that is the drawbar complete. We've got the body turned to diameter, we've got the register so that it fits, we've got the threads cut on the end, and now we've got flats on the other end to turn it with a wrench. Let's see how it fits. If you remember, way back at the beginning of this project, we hardbored a register in the back end of the spindle here. Now this is hardened material, and the center hole was just drilled, so it wasn't concentric, and I didn't want the drawbar flapping around in there, so I bored a register, and that's what this step on the back of the drawbar is for. So the drawbar slides in, that register engages, and it just fits perfectly. There's no play in that at all, but at the same time, it turns easily. So that is going to be just perfect. It's going to stay centered, and the flats are just perfect for a 16mm wrench. So I think that's going to work well. That's it for today. Next time we are going to start on one of the wheel arbors. If you're enjoying this video, please give me a thumbs up, comment, subscribe. Thank you for watching.